So uh, let's go ahead and talk about some rules here. So this means derivative of some function, or ddx of some constant c. So if I take the derivative of a constant, as long as it's a constant, that the derivative of that constant will always be 0. And yeah, it makes sense. If I have a horizontal line, look, these are all constants. Y equals 5, y equals -10, y equals, I didn't count how many zeros there are, so I don't know if that's a billion, 10 billion, or 100 billion. Do you guys agree that the slope of a horizontal line is 0? Yeah. So check it out. I'm going to write dy dx equals 0. That means derivative. Another way to say derivative, I'm going to say y prime equals 0. I'm just going to say y prime again. Y prime equals 0. And that's it. You're done. So the derivative of any constant is always 0. Always, 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 always. And that's it. That's how easy it is. Was that easy? Yeah. Well, no, we got one more rule. Now we got a power rule. And it's called rule 2. Who cares what it's called, right? All right. So you have this rule here. So how would we find these derivatives without the rule back in the day, like yesterday? So yesterday we would find this derivative. I'm doing this one in particular right here by saying f prime of x equals limit as h approaches 0 of f of x plus h minus f of x all over h, correct? And then from there you did, okay, let's expand this x squared here with the x plus h. So limit as h approaches 0, x times x is x squared, x times h is xh. You're going to have two of those when you add them up. H times h is h squared minus x squared all over h. I just expanded it. Those x squares zero out. I can factor out an x squared. I can factor out an h, sorry. Limit as h approaches 0. Here's my h factored out. And you get 2x plus h all over h. And then those h's cancel out. And then you can make h approach 0 and you get 2x. That's how we used to do it. Well, we still do it that way, but that's how. This rule here, as long as it's a variable, notice it says x with the power n, where n has to be a number. N must be a number. Tells me that I can just drop whatever number that is in the front and then just subtract 1 from it. Let's see if it works. No, that's what it says. Let's see if it works. F prime of x. So I have a 2 here. Let's see, can I drop that 2 in the front? 2 in the front, and then it says subtract 1 from whatever that degree is. Oh, to the power 1. Oh my God, look at that. One little rule just helped me save all from doing all that stuff again. The derivative of x squared is just 2x. That's it. I just followed the rule. So let's see if we can follow this rule. You could find the limit as this approaches, as h approaches 0 and do all that stuff, or you can just use this rule. It's always going to work, guys. Bring the 7 down, subtract 1 from that degree. There it is. That's the derivative of letter B. I know you guys are looking at me. Well, you guys can't look. I can't tell, but these two are looking at me like, whatever, Chavez. Well, yeah, but we got to learn it by limits first. Bring that -5 down, x to the -6. Chavez, I don't know how to do letter D. Letter D doesn't have an exponent. Yes, it does. It's a radical. What exponent does it have? 1/2. F, well, look, I'm not even doing the derivative yet. I'm just rewriting it. So here we go, using my rule. F prime of x equals 1/2 x. I'm going to subtract 1 from that exponent to the -1/2. What does that mean? F prime of x equals 1 over, I guess you can say 2 there, right there, x to the 1/2. Make it even prettier than that. F prime of x equals 1 over 2 square root of x. Do you see how we did it, guys? Are we okay? Okay, hello, miss. All right. Next. Oh, what happened? Okay. All right. Don't freak out. This just says I have a constant times my variable x squared. So this is telling me that I can leave the constant alone. And I can just take the derivative of the inside. So look at this. So here's my constant. There's no plus or minus. I'm going to say y prime equals 5. And what's the derivative of x squared? You just said it. 2x. What's 5 times 2x? That's what I would do. I wouldn't even bother with the intermediate step. Y prime. Let's see how fast you guys can do it. 7 times, what's the derivative of x cubed? Yeah. What's 7 times 3? I wouldn't even bother with the intermediate step, guys. I wouldn't bother. I guess it helps, but I wouldn't bother. So Chavez, what are you talking about that you don't bother? This is what I'm talking about. I would just go ahead and just multiply right out. What's negative 20 times 5? Negative 5. 100 x to the, no, so we're subtracting 1. There it is. You weren't here for the, we did a rule. We'll catch you up real quick. All right, you guys tell me, what's the answer for letter D? Look, rewrite it. Yeah, you're right. It is 4. 8x to the half. So I rewrote it. What is half of 8? 4, and then I'm subtracting 1 from the exponent. So that's x to the what? Negative 1/2. So y prime equals 4 over x to the half. Yeah, that means 4 over square root of x. Does that make sense, guys? Okay. All right. All this is, and relax, we're so good. The sum and difference rules just says that you can apply it to any polynomial. Any polynomial, you can do the term individually. That's all it means. Do we understand that, guys? So, basically, take derivative of every term in a polynomial. And that's it. That's all we know. And we're probably going to stop in a little bit. All right. This means take the derivative of p with respect to t. Those are all t values. So we're good. I'm going to write dp dt equals, what's the derivative of t cubed? 3 what? T squared. Plus, what's the derivative of 6t squared? 12 t. Minus, what's the derivative of 5/3 t? You probably already figured it out, right? That's just a linear term. You know, 5/3. And that's it. The derivative of a constant is 0. Chavez, how come we didn't follow the rule with the 5/3 t? Well, we did, guys. If you follow the rule, so here it is, look. D dt of, I'm just going to keep it positive, 5/3 t. Well, that's the power of 1. 5/3 times 1 is 5/3. And then subtract 1 from 1 is 0. What's anything raised to the 0? 1. So you just get 5/3 anyways with the rule. Oh, I'll get back to you in a little bit, miss. Don't worry. We'll get back. I promise. Are we still okay, guys? Okay. So now let's see if we can do some problems. It says, example 5, finding horizontal tangents. Does the curve y equals x to the 4th minus 2x squared plus 2 have any horizontal tangents? If so, where? Of course it does. It has a whole bunch of little hills. Of course it has horizontal tangents. I don't know exactly how it looks, this graph. It may look something like that. But I have horizontal tangents wherever I have my little, whenever this graph goes from increasing to decreasing or vice versa, right? I don't exactly know how it looks, guys. I just have an idea of how it looks. Okay, so here we go. I'm going to take my derivative, and I'm going to equal that derivative to what? 0, because horizontal tangent means slope of 0. So let's put that in your notes. This means tangent lines have slope of 0. Really, the horizontal is what says that. So here we go. Y prime. Look how beautiful this is. You don't have to do the whole limit process anymore. What's the derivative of x to the 4th? 4x cubed minus, what's the derivative of 2x squared? 4x. I'm going to equal that to 0. I'm going to factor out a 4x. I'm going to get x squared minus 1. I notice that I'm going to get 3 answers. If you want, you can expand it. You can say 4x, x minus 1, x plus 1. One answer is 0. One answer is 1. One answer is negative 1. At these 3 locations, I have horizontal tangents. Let's see if that's true. I just want to see it, guys. I just want to see it on Desmos. So let's see if that's true. What was the equation again? Y equals, let me get the right Y. How do I see this problem is happening? There we go. I just want these guys. Y equals x to the 4th. Oops. X to the 4th minus 2x squared plus 2. Look at that, guys. I had an idea, but I didn't know exactly. At negative 1, do I have a horizontal tangent? Definitely. At 0, do I have a horizontal tangent? 100%. At 1, do I have a horizontal tangent? Yeah, I definitely have horizontal tangents there. Good job. So here we go, guys. I think we can do question. Yeah, we can do this one. Question 6. A random question I stole from your textbook if we use textbooks. Find the tangents to the curve y equals x cubed plus x at the points where the slope is 4. What is the smallest slope of the curve? What is the smallest slope of the curve? And what values of x does the curve have this slope? Okay. So let's see if we can answer the first part. You okay, Tiff? Yeah. Okay, because you look like you're. All right. Find the tangents to this curve where the slope is 4. All right, let's do that. Y prime equals 3x squared plus 1. And I'm going to equal that to what? 4. What point? Okay, so I'm going to solve for this, guys. Minus 1. So 3x squared equals 3. I just subtracted 1. Divide by 3. I have x squared equals 1. And square root, I have x equals plus minus 1. So at these values, I have a slope of 4. Now, it also wants to know what is the smallest slope of the curve, of this curve. Well, look, this expression, 3x squared plus 1, tells me the slope of all my curves for any x. Does that make sense to you guys? What is the smallest this expression will ever be, or this argument will ever be? 1. That's it. That's the smallest. So does that make sense or no? No? Okay. If I were to graph this graph looks like this. It's a parabola. This is not my y graph. That's my y prime. What is the smallest y prime value that this slope ever gets? The smallest y prime value is 1. This is the graph of the slope. This is not the graph of y equals x cubed plus x. then yeah, then if this was a graph of y, then you would say the smallest slope is 0, which happens at 0. All right, so here we go. I'm going to say the smallest, I got to answer the question, so I'm going to say the smallest slope of this curve is 1. If they want to know at what value of x does the curve have this slope, oh, they do. They want to know this occurs at x equals 0. There it is. No, on the y prime, at 0, my slope is 1. Like that just means my slope for y. So at my x coordinate is 0 here. So that means my x coordinate is 0 on this one where I have the smallest slope. You know what I mean? All right. All right, so if you have two things that are being multiplied, u times b, it says first times the rate of the second plus second times the rate of the first. Chavez, I don't understand what you told me. When I say first, I mean like the first argument or first element. And when I say second, that means the second argument or the second element after the first. So first times the rate of the second plus second times the rate of the first. Product rule is the easy one. It does not matter the order. So that's why sometimes you'll see textbooks that will actually switch up the order. And they do that on purpose because the quotient rule, what they do is I think they introduce the quotient rule first. And then after they introduce the quotient rule, they like to keep the patterns the same. And they just switch the plus to a minus. So maybe that would have been the better route to introduce it. But I already typed out the notes. So too bad. I left it like this. Yeah, the other way would have been v du dx plus u dv dx. For the quotient rule, minus. All right, here we go. Before I take the derivative, guys, because see, I have a product. Let's do the derivative the way we know by first, let's find an expression in a polynomial and then take the derivative. So let's multiply this out. X squared times x to the fifth. So all I'm doing, I'm not taking the derivative yet. I'm just multiplying out. X squared times x to the fifth, that is x to the x cubed, sorry, is x to the fifth. X squared times 3, 3x squared. 1 times x cubed, and then 1 times 3, that's 3. Putting it in order from highest degree to lowest degree, x to the fifth plus x cubed plus 3x squared plus 3. Taking the derivative, f prime of x. All right, let's see what that derivative is. What's the derivative of x to the fifth? Yeah, derivative of x cubed. Derivative of 3x squared. And the derivative of a constant. All right, so this is what I should get. I'm going to follow my product rule. So here we go. I'm going to say that blue, or whatever color this is, in case you're colorblind. I'm going to say that that is product rule. Well, because I don't know, miss. I mean, you know, what if someone's colorblind? Or what if some of my fans are colorblind that watch my YouTube video? So give me a thumbs up. Not right now, but after, okay, I'll stop. Yeah, that just deserved a thumbs down there. So probably someone, yeah, don't give me a thumbs down. That's just mean. You know, I mean, unless you feel like you're not getting a quality education here. All right, product rule. I'm using this. So it says I'm going to write f prime of x. And it says first, to leave the first alone. So I'm going to call that u. I'm going to call the double underline v. So first, so I leave it alone, x squared plus 1. And then it says dv dx. So that means derivative of the second. So the derivative of x cubed plus 3 is just 3x squared. Cool. And then there's a plus, so I put a plus. And then it says derivative, it says v. So I write v alone, x cubed plus 3. And then it says du dx. So I take the derivative of x squared plus 1. And the derivative of x squared plus 1 is 2x. Cool? All we're doing now is algebra. I cleaned it, so yeah, don't use that chair. Oh, yeah, you're good. So here we go. I'm just going to distribute, guys. I'm just doing algebra because I already found the derivative. 3x to the fourth plus 3x squared plus 2x to the fourth plus 6x. And at first glance, you're like, Chavez, that does not even equal what you had earlier in red. And no, it does. Combine like terms. Add them up. 3 and 2, 5x to the fourth, plus 3x squared, plus 6x. OMG. Look at that. Is it the same? Yeah, it is the same. So why can I not just take a derivative immediately of a product? Because it doesn't work that way. If you want to see the proof, come by after school, or I guess Khan Academy I think has the proof in there as well. If you, or you know what, just go to YouTube and put proof of product rule, and it's like a 10-minute video, and you can watch it. And then if you want to see the proof of quotient rule, you can put proof of quotient rule in calculus, and you can watch it. And together, you'll probably spend like 30 minutes together. Excuse me. Okay, so here we go. Wow, I thought I was going to write a lot more than that. So here we go. Working with numerical values. So I have an expression, y equals uv. And it says, let that be the product of the function u and v. Find y prime of 2 if u of 2. So here are my values. Sorry, guys, I'm not farting. That's just the lawn. That's just a machine outside cutting grass. So here we go. I want the derivative of y, so y prime. And really, I should be putting y prime of some variable, but they don't tell me with respect to what. So I'm just going to put y prime. So I'm just doing the rule. First times derivative of the second. You can put a b prime on it, or you can write dv dt or dv dx. Plus second derivative of the first. So that little prime there means derivative. Okay, are we all, do we understand that, guys? All right, so now there's my rule. I'm going to find it. Y prime of 2. They don't tell me what variable this is with respect to. It just says they're just products there. Equals first, so u of 2 is 3. Times derivative of the second, so v prime of 2 is 2. Plus second, v of 2 is 1. Times derivative of the first, u prime of 2 is negative 4. And there it is, guys. It really is that simple. 3 times 2 is 6. 1 times negative 4 is negative 4. 6 minus 4 is 2. So y prime of 2 is nothing more than 2. Are we okay, guys? All right. So there it is. That's the product rule. So remember when I told you that some textbooks have this order, this order right here? They do that on purpose because look at this, look at the sequence for this. And there's a song, we're all gonna sing the song together in a little bit because you guys say that I don't do fun stuff, which I think this is fun all the time anyways, right? But at a point where v is not equal 0, of course, because if v is 0, you can't divide by 0. The quotient u divided by v of two differential functions is differentiable at, and here's how you say it. Bottom derivative of the top minus top derivative of the bottom over bottom squared. See? This, every textbook has that. Yes, bottom derivative of the top minus top derivative of the bottom over bottom squared. That's right. Like Drake says, you started from the bottom, now you're here. So you always start from the bottom until you get there. Okay, that was the dumbest thing I've ever said. All right, so what's that song I was talking to you about? And I'm not kidding. Some of you will I'll probably hear you say this little song as we get close to the AP exam. I'll still hear it. I think you already have it memorized, but for whatever reason, you guys still like to sing it. Here's how you say it. Low D high minus high D low over low low. I'm gonna say it again. Low D high, so low just means bottom. And then as soon as you say D high, D stands for derivative. So derivative of the top, because high is the top, right? Low D high minus high, just high, D low, D stands for derivative of the bottom, low, over low low. Low times low, low squared. See? So repeat it with me. Low D high minus high D low over low low. Guys, I didn't hear you guys repeat it with me. Part of your grade is participation. So repeat it with me. Ready? On mic. Everyone on mic. Of course, everything's not synchronized, so we're all going to be off. But that's okay. On mic. 3, 2, 1. Low D high minus high D low over low low. We're going to do it one more time, guys, because I'm not hearing you guys. 3, 2, 1. Low D high minus high D low over low low. Okay, one more time. 3, 2, 1. Low D high minus high D low over low. All right, thank you guys for participating. I heard them. There were like maybe 4 of them. Everyone else was like, nah, I'm not gonna say it. I'm too cool. All right, you 2 cool people. You guys better make sure that you get these questions right. Okay, you guys ready? All right, quotient rule. Let's do the quotient rule. So here we go. I'm gonna write it in red. I'm gonna say f prime of x, and I'm gonna use my little song, low D high. So I say, oh, okay, I'm gonna put low. So bottom, and then it says D high. Oh, that means derivative of the top. So the derivative of x squared minus 1 is 2x minus high D low. Oh, okay, high x squared minus 1. D low, derivative of the bottom, 2x over low low. That just means bottom squared. If you don't like the song, just use the formula. Bottom times derivative of the top minus top times derivative of the bottom over bottom squared. Or sing your little song. All right, we're done. Now you just do a little bit of algebra. So let's see what we get here. 2x cubed plus 2x minus, and then I still haven't distributed the negative, guys, so I'm going to put all this in parentheses here. 2x cubed minus 2x all over. I'm not going to bother expanding the denominator unless you have to. We don't have to. So now I'm going to distribute the negative. 2x cubed plus 2x minus 2x cubed plus 2x. Ooh, it looks like we're going to have something kind of cool. So f prime of x is equal to, let's zero out with zeros out. 2x cubed, 0 out. 2x plus 2x is 4x. So 4x over x squared plus 1 squared. There it is. That's my derivative. If you want to see why the derivative came to be, go to YouTube, or come ask me, and we can do it. And put proof of quotient rule. I think Khan Academy has it as well. I think, if I remember correctly. They're all the same, by the way. Every single proof. There's slight variations, but there's one really popular one, and they all have it pretty much the same. They start off by saying, what's the concept of taking a derivative? It's an instantaneous rate of change. And then they'll have like a square. And, well, okay, I already said too much. You can, if you want to see the proof, go ahead and YouTube it. If you just want to know the rule, here are the rules. Cool? All right.
Wait,
all right.
So we can just leave the denominator like that, right?
Yeah, that's perfect.
Okay, thank you.
So here we go. It says find an equation for the line tangent to the curve y equals x squared plus 3 over 2x at the point 1, 2. All right, so I need 2 things. I need a point, which I already have. I want a tangent line, by the way. I need a point, which I already have, and I need one more thing. What else do I need? A what? A slope. So write that down. For a tangent line, you need 2 things: point and slope. Point and slope. Point and slope. So how do I take my derivative of this? What rule do I got to use? Quotient, the rule that we just learned. So here we go. Y prime equals low D high, 2x times derivative of the top, D high, 2x, minus, and remember it's minus, low D high minus high D low, x squared plus 3 times derivative of the bottom, 2, over low low, over 2x squared. There it is. I want to know what my slope is when x is 1. That's what I'm going to plug in. Y prime of 1 equals, let's see, if I plug in a 1, I get 2 times 2, which is 4, minus, if I plug in a 1, yes, I could have simplified it over here, but I decided to be lazy here. 1 squared is 1, 1 plus 3 is 4, 4 times 2 is 8, over 2 times 1 is 2, 2 squared is 4. So I have negative 4 over 4, so my slope is negative 1. Now that I know that that's my slope, y minus 2 equals negative. And you don't have to put a 1 in there, but I already did. X minus 1. I'm going to stop right here. I'm going to call that a tangent. Desmos will do it for me. We're going to find out right now. You guys ready? I'm going to click on Desmos. Come on, buddy. Desmos. I guess, nope, I'm not gonna do it. I'm gonna have to just stop sharing. Graphing calculator, I do wanna graph this time. All right, in here, I'm gonna type in my equation. What was it? Y equals what? Y equals, what was in the top? No, not the tangent line, the original equation. That's in the top though, right? So put that x squared plus 3 over 2x over 2x. All right, there it is. And where do I want my tangent load? At what point? So I'm gonna put my point in here. Look how awesome this is, guys. Man, look at what all this stuff we can do. So there it is. There's my point, 1, 2. I'm gonna push enter. Okay, now give me my tangent line. Y minus what? 2 equals, where's equals? And then negative, parenthesis, x, was it x plus something? No, x plus 1, right? X minus 1. Yeah, that definitely looks like a tangent. Look at that. Look how beautiful that looks. Isn't this awesome? By the way, you can do all this with a calculator, but it just feels so much better to use all this real estate on Desmos. So Desmos is so powerful, guys. Start using Desmos. The more technology you can use, you future engineers, this is what you're going to be doing. Of course, the graphs are going to mean something, right? So the graphs are probably going to mean like the amount of stress produced per square inch of force applied or something like that. And then you're going to see like this is saturation. You cannot pass this tangent line, and anything after that is going to be it's going to be probable for failure, stuff like that. So you engineers, you're going to be working with all this technology. I hope that you get excited about every time we do stuff like this. But yeah, anyways, let's go back, guys. So here it is. A lot of you are probably pros already because I saw a lot of you already completed it and it said higher order derivatives and you guys already had 100. Yeah, it's really easy stuff. So you already know that this stands for derivative. Y prime equals dy dx. So why does this stand for second derivative? Well, look, it's because if you're saying take the derivative of a derivative, look at this. How many d's do you see there? 2 of them. Derivative with respect to x, and you have 2 dx's. And I know it's understood. You're like, but that x is for the square there. It really is understood to mean that the dx is being squared. But yeah, and it's always going to look like that, guys. So if you want to know how it's going to look always, it's going to look like this, where n is a number. N is an integer, a positive integer. So what am I trying to say? Chavez, what are you trying to say? If I say this means what? This means fifth derivative. Do we understand that, guys? Okay. Let's see what I wrote in here. So, okay, remember what a derivative is? Before I continue, I want to make sure that you guys understand. A derivative is an instantaneous rate of change. Do we understand that, guys? So if I'm taking a second derivative, think about what you're actually doing. You're finding the rate of change of a rate of change, like how fast something is changing. Does that make sense to you guys? Eventually, the more derivatives you take, it's not going to mean anything anymore. Eventually. So I know a lot of you, well, okay, I'm seeing 3 people here, so I can tell you what faces they're making at me. So I know a lot of you are saying like, okay, I don't understand, Chavez. What are you trying to say? Okay, imagine I have a position graph, just position. What does my first derivative tell me of my position graph? A graph that just tells me where I am, at what location I am. Instantaneous rate of change, my position divided by, or distance traveled divided by time. What is that? Yeah, the speed. So if I have a position graph, the derivative tells me the velocity. Okay, what if I do a derivative of the velocity? So think about what you're doing now. You're finding acceleration, the change in velocity divided by time. So that is, with respect to the position, that is the second derivative. Do you see what we did there? If I take another derivative, there's something called, maybe we're getting ahead of myself here, guys, but if I take a third derivative with respect to position, that's called a jerk. So if you want to be mean to your boyfriend or girlfriend, because I don't judge, if you want to be mean to them, you call them and say, look, you're being the third derivative of position. And then when they say, no, and when they say, I don't know what you're talking about. Well, go find out, learn something, and then hang up on them. And they will literally go, third derivative of position. And they'll say jerk. Like, oh, she just called me a jerk. So now you know the third derivative of position is called a jerk, guys. So, text your boy or your girl that when you're mad, don't just use it up right now. Whenever you're mad, and then just hang up on them. Like, well, go when they tell you, like, I don't know what you're talking about, babe. I don't know if they call you babe or not, but I don't know what you're talking about, Christine. I mean, I don't know or Sonia or whatever his name is. What's a good name? Zach. I don't know what you're talking about, Zach. Like, well, go find out, and then hang up on them, and then they'll find out. Okay, why did I go into that? Because of higher order derivatives. All right. There is an activity later on that talks about that, but maybe we got too advanced right now for you guys, but hopefully I wanted you guys to know what we're doing here when we take multiple derivatives. Find the first four derivatives. All right, y prime. First derivative of x cubed, that is 3x squared minus the derivative of 5x squared. 10x, and then the derivative of a constant is 0, so we're done. Second derivative, I put y prime prime. The second derivative of this expression is minus 10. The third derivative, I put 3 primes, prime, prime, prime. Yep. And it said fourth derivative. Are you going to put 4 primes? You can. I'm going to put Roman numeral 4 in parentheses like that, so they know that we're not talking to a power 4. And I know what you're thinking. You're saying, hey, are those like Roman numerals 1, 2? No, they're called primes. It's just that anything higher than 3 is too much to just keep writing little sticks. So just put it in Roman numeral. I've also seen them with numbers, by the way, too. Or just do this, like what we did over here. d4y over dx to the fourth. You can also say that. You know what? We'll put both of them in there. Y to the fourth, which equals d4y over dx to the fourth equals, what's the derivative of 6? 0. Eventually, all functions, if you keep taking derivatives, eventually, because there's no more rate of change of a rate of change of a rate of change of a rate of change. You keep taking a derivative of any function, except for, okay, I'll take it back, because we haven't studied sinusoidals that are waves. You take a derivative of any polynomial function except for waves, eventually you will stop having rates of change, eventually. Now, if something is moving up and down like a piston, there's a lot of force going on that, because it's like a wave, and those have rates of change of rates of change of rates of change of rates of change of rates of change. You can go forever on that. But any polynomial eventually will zero out, always. All right, I think we're ready now to do these rules. Are you guys ready? What rule do I got to use for letter A? Product. That ddx means take a derivative. So as soon as you see that, I'm just going to write the derivative now. I'm going to put the equal. And derivative of a product rule is first times root of the second. I'm sorry, there's no little song for that. Plus second times root of the first. If you want to switch it up, so you can look similar to the quotient rule, you can. You can write the vu prime plus v prime u. Several textbooks do it that way. Khan Academy does it that way. But I already wrote the notes, so I'm just going to write it like that. All right, first. So I'm going to go first, 5 times root of the second. I look for v prime. V prime of 0 is 2, plus second, so that's -1, the v, times root of the first, -3. Let's see what that is. 10 plus 3, I got 13. Excuse me. So that's 13. Letter B, what rule do I use? Quotient. Low D high, so v, let's see, where are you, v? -1. Low D high, derivative of the top, so u prime, -3, minus low D high minus high D low. So the top is u, so I'm going to put -5. Low D high minus high D low. So now I'm looking for the derivative of the bottom. Did I mess up? No, I didn't. 2. All over bottom squared. -1 squared. Bottom times derivative of the top minus top 5 times rid of the bottom 2. Yep, everything looks good to me, guys. So let's see what we got there. 3 in the top, 3 minus 10, that's a negative 7. So negative 7 divided by negative 1 squared, so I'm just going to get negative 7. Everyone see how we got that? All right, what am I going to do on this one? Quotient rule again, low D high. So I guess let me write it out first so you guys don't get confused. Bottom, low, D high, so derivative of the top minus top, derivative of the bottom, minus high, D low, over low, low. And now I'm just gonna plug it in. So U is 5, V prime is 2, V is negative 1, and U prime is negative 3, over U, which is 5 squared. So we get, let's see, 10 minus 3, which is 7 over 25. Negative times the negative is a positive, but then I'm subtracting again, so minus 7. And then this one is just straightforward. You already know this one, guys. This is just 7 V prime minus 2 U prime. Your regular rule, power rule. The derivative of V is dv dt or V prime. Derivative of U is just U prime. Are we okay or are we confused there? Yeah, with respect to X. So they're saying all these functions are in terms of X. That means deriv. Is everyone okay with that right there, guys? That expression? Nothing. D dx means take the derivative with respect to X. Dy dx means that they told you that the function is Y, and they want you to find the derivative of Y with respect to X. 7 times V prime is 2, minus 2 times U prime is negative 3. So what's that? 14 plus 6, 20. How do we feel, guys? Yes. Y equals, that's a Y, just came out dumb. 3 over 5, and then you have something like the 4th root of X. So if you have something like that, and they want you to take a derivative, here's what you're going to do first. First, write 3 over 5, and then the 4th root of X means X to the 1/4. And then I'm going to bring this up. So you can say Y equals, and I'm going to write it as 3/5 X to the negative 1/4. Does everyone see how I did that, guys? So now, if I want to take the derivative, I can use my power rule, very simple. Y prime equals, and I just take this right here, and I multiply by 3/5. So that times that, so let's see, I'm going to have a negative 3 over 20, and nope, I don't see that reducing. X to the negative, so how do I do it now? Remember, you're subtracting 1, so make it like 4 over 4. So negative 1 minus 4, that's a negative 5, so negative 5/4. How do you turn that into a positive? Bring it back down. Negative 3 over 20 X to the 5/4. And I believe delta math will accept that. Will delta math accept that, guys? Okay, so they don't accept that. Will they accept this? Negative 3 over 20 4th root of X to the 5th. Okay, so there it is, guys. That's how you would do that. By the way, the 4th root of X to the 5th is an X. So I think you can take out an X as well and say 4th root of an X. But you can leave it like that and it'll work. Let me do one more example. Has anyone come into the room? Only one? Oh, man. Okay. Let me do one more example, guys. And I'll put this on for the notes there as well. So I have Y equals, what's your favorite number between 1 and 5? 4. Over, and then let's do, what's your favorite number between 2 and 5? Not including 4, because 4 over 4 is 1. No, that's not, oh, you know, I should not have, I'm sorry. I should not, because 2 reduces, so I only have one option there. Okay, 3, and then what's your favorite root number? 7, all right, 7th root of x squared. All right, if you have something like that, rewrite it. 4 over 3 x to the 2/7. And remember what I said, bring the x to the 2/7 up. So here it is, I'm not taking the derivative yet. So here's 4/3. If you want to put the x to the 2/7 to the negative 2/7 next to the number 4, you can, but I like to do this, guys. I like to do it like that. Because it's easier for me. Because it's easier because I see a fraction and I'm multiplying by a fraction here. So now look, y prime equals, well, 4 times 2 is 8, but I'm going to write negatives. I'm going to put negative in the front, 8 over, and then 7 times 3, 7, 14, 21 is 21. We'll talk about reducing if it reduces. Does that reduce? 8, 16, 24. Nope, it doesn't reduce. Here we go. X to the, you take this exponent and you subtract 7 over 7, because that's a 1. So 7, 8, 9. So negative 9/7. There it is. So let's rewrite it. Y equals negative 8 over 21 x to the 9/7. Next, it says my internet connection is unstable. Are you able to still see me? Okay. Next, that message went away, so now I'm good. By the way, this is the derivative. I didn't even put the y prime there. Y prime equals negative 8 over 21, 7th root right there, x to the 9th. That actually breaks down if you wanted to. You can bring an x out and you would have x squared on the inside, but I think delta math will take that. Do we understand, guys? Did it make sense or no? All right, let's come back really quick.